This video is on two-source interference. Question 1. Answer the questions related to the image below. So take a look at this. What do the solid blue lines represent? Solid blue lines are crusts formed from source A. Part B. What do the dotted blue lines represent? Dotted blue lines are troughs formed from source A. You have to remember what crusts and troughs are. Crusts are the top part of a wave, troughs are the bottom. Part C, what do the solid red lines represent? Solid red lines are crusts formed from source B. And finally, what do the dotted red lines represent? Dotted red lines are troughs formed from source B. So take a look at this image, kind of like memorize it. You notice there's a place where the solid red line meets a solid blue line. And there's also a place where a dotted red line meets a dotted blue line. And there's also a place where a solid red line meets the dotted blue line. And there's a place where a dotted red line meets a dotted blue line. So, part E, what occurs when two solid red lines cross? If two solid red lines cross, then constructive interference occurs at that location. So we have maximum displacement when two solid lines cross. It could be red, red, or blue, blue. What occurs when two dotted lines cross? If two dotted lines cross, then constructive interference occurs. There's a minimum displacement. When two solid lines cross, we get a maximum displacement. When two dotted lines cross, we get a minimum displacement. Finally, what occurs when a solid line crosses a dotted line? We get destructive interference. We get zero displacement. So, once again, up here it says constructive. We have a solid line meeting another solid line, or a dotted line meeting another dotted line. And on the bottom we have points of destructive interference, where a solid line meets a dotted line. So that's the meaning of two-source interference. Question 2, for double source interference, state the equations for A, constructive interference. Constructive interference is when the path difference, which is x1 minus x2, meaning the length from the source to point x1 minus the source to point x2 is equal to n lambda. Where the path difference is the difference in length from one point source of waves to another point source of waves. N is a positive integer, 1, 2, 3, 4, 5, and lambda is a common wavelength of the two sources. Where we have location for destructive interference, it's when the path difference is equal to n plus 1/2 lambda. So we have an n lambda on the right side, we have an n plus 1/2 lambda on the right side. Let's try to apply those two equations. Two coherent sources vibrate in phase with a wavelength of 10 meters. So we have source 1, source 2 in this image. Determine if points A and B are locations of constructive interference or destructive interference. So take a look at this equation up here for constructive interference. Path difference equals x1 minus x2 equals n lambda. So look at location, look at point A. The path difference is 20 meters minus 15 meters, that's 5. So the path difference is x1 minus x2, which is 5 meters. Now let's try to set that equal to, we're going to have to take a guess. It's either n lambda or n plus 1/2 lambda. Let's use n plus 1/2 lambda. What is lambda? It's the wavelength. They told us the wavelength is 10 meters. So the path difference is 5 on the left side. Lambda is 10 on the right side. So if we have n plus 1/2 on the right side, and we let n equal 0, we could get 5 on the left side and 5 on the right side. So point A is a path of destructive interference. Now take a look at point B. What's the path difference at point B? It's going to be 20 minus 10, which is 10. That's the left-hand side. Now what's the right-hand side? We have to take a guess. It's either n lambda or n plus 1/2 lambda. So if it's not one, it's the other. So let's try n lambda. We know the wavelength is 10. So we'll let lambda be 10. So if the left-hand side is 10 and the right-hand side is n times 10, n has to equal 1. So this is the equation for constructive interference. Question 4. Two coherent sources vibrate in phase with the wavelength of 4 meters. Determine if points A and B are locations of constructive interference or destructive interference. So the wavelength is 4. Let's take a look at point A. The path difference is 20 minus 16, which is 4. And that's equal to n lambda. Lambda is 4 because the problem gives it to us. So 4 is on the left side and n times 4 is on the right side. So n is 1. So point A is a location of constructive interference. Now take a look at point B. What's the path difference to point B? It's going to be 20 minus 6. That's 14. So 14 is on the left side. Okay. What's on the right side? It's n plus 1/2 lambda or n lambda. Lambda is 4. So we're going to have 14 on the left and 4n or 4n plus 1/2 on the right. So if you put a 4 and then we multiply it by 3 plus 1/2, we get 14. So point B is a location of destructive interference. So that is two-source interference.